Good day everyone, I am Joy Bida Malario, a third year BS Mathematics student. In this video, I am going to discuss about vertex coloring. But before that, let me first define what is graph coloring. Graph coloring is a simple way of labeling graph components such as vertices, edges, and regions under some constraints. In a graph, no two adjacent vertices, adjacent edges, or adjacent regions are colored with minimum number of colors. Vertex coloring, edge coloring, and map coloring are some examples or types of graph coloring. But in this video, let's focus on vertex coloring. So what is vertex coloring? Vertex coloring is an assignment of colors to the vertices of graph G such that no two adjacent vertices have the same color. Simply put, no two vertices of an edge should be on the same color. Like for example, in this graph, we use two different colors, and 2 is the minimum number of colors such that no two adjacent vertex has the same color. So, unsa day tawag natong gina-term nga minimum number of colors? So, that's what we called chromatic number. A chromatic number is the minimum number of colors required for vertex coloring of graph of G, which is denoted by chi of G. Chi of G is equal to 1 if and only if G is a null graph. If G is not a null graph, then chi of G is greater than or equal to 2. Let's consider this example. As you can see, there are two graphs. The first graph is represented as null graph, which has 4 vertices and uses only one color. It is because those vertices are not adjacent to each other. That's why it is chi of G is equal to 1. The second graph is represented as the not null graph, which also have 4 vertices but uses 2 colors. It is because there are vertices that are adjacent to some vertices. That's why chi of G is equal to 2. Another thing to remember is that in the complete graph, each vertex is adjacent to remaining n-1 vertices. Hence, each vertex requires a new color. Hence, the chromatic number of k of n is equal to n. So as you can see in this example, graph K4 has 4 vertices. So K4 is a complete graph. That's why the chromatic number is 4. So chi of G is equal to 4. A graph is said to be K-colorable if it can be properly colored using K colors. Like for example, in this graph, it is a bipartite graph, and we all know that a bipartite graph is a set of graph vertices decomposed into two disjoint sets such that no two graph vertices within the same set are adjacent. So as you can see in this example, there are two sets, no? The vertex with the color of blue, and the second set which have two vertices and color it with red. So kaning duha ka red is pwede gid na siya nga same na sila, muna tong gibuhat duha ka red kay dili man sila adjacent, unlike aning blue and red nga adjacent. So that's why ato silang gilahi og color kay adjacent sila. So now we can say that this bipartite graph is two colorable. A K-coloring of a graph is a proper coloring involving a total of K colors. A graph that has a K-coloring is said to be K-colorable. Like for example, in this graph, as you can see, it is a cycle 5, so it has 5 vertices and uses 3 different colors. So it is called 3-coloring and 3-colorable. So, diba, as you observe, vertex coloring is hassle good, especially when it is the graph is complicated na. Kay daghanay vertices and we need to get the chromatic number, which is the minimum number of colors nga atong magamit ana nga graph. Unlike anang simple graph lang na, so dali ra gid kayo nato makita na kung dili na to ma-identify kung pila ka colors atong magamit, unlike sa mga complicated ones. So naay steps para mas dali ang atong kuan sa pag-color sa atong mga vertices. Like step 1, arrange the vertices of the graph in some order. So kani like ato ning magamit pag kanang complicated graphs na. ato siyang first ato silang i-order, like atong pangitaon ang mga degree each vertices, and then after na maplasar nimo, dito sa step 2, choose the first vertex and color it with the first color. So katong pinakataas og degree mo to imong unahon og color, like example atong color og red. Then next is katong yung kuan, like ang nagsunod sa iya nga degree, like ana. So step 3, choose the next vertex and color it with the lowest numbered color that has not been colored on any vertices adjacent to it. So ana, mangita na tag vertex nga adjacent or dili adjacent ana para ma-identify nato kung unsa tong ibutang nga colors. So after ana is repeat lang sa step 1, step 2, and step 3. So here are some examples of vertex coloring. So in the first graph, it is W6. So its chromatic number, the chromatic number rather, is chi of G is equal to 4. The other graph is K4. The chromatic is chi of G is equal to 4. Next is the K3. Chi of G is equal to 3. K2, chi of G is equal to 2. C4, chi of G is equal to 2. And W7 is chi of G is equal to 4. So, di ba, dili naman siya yung complicated nga mga graph. So, dali ra gid nato nila sila ma-identify ang ilahang mga chromatic numbers. So now, let's proceed to the real-life application of graph coloring. So, ang graph coloring din is dakong tabang din na siya, labi na pag we solve problems, like ma-apply na to siya sa real-life scenarios. Like for example, in solving Sudoku's puzzles. So, how graph coloring kanang makatabang when we solve Sudoku puzzle? So, Sudoku is a popular puzzle with a 9x9 grid that needs to be filled with numbers from 1 to 9. A few numbers are given as a clue and the remaining numbers needed to be filled follow a simple rule. They cannot be repeated in the same row, column, or region. This puzzle, despite using numbers, is a mathematical puzzle, but a combinational puzzle that can be solved with the help of graph coloring. One can convert the puzzle to a graph. Here, each position on the grid is represented by a vertex. The vertices are connected if they share the same row, column, or region. This graph is an undirected graph, since the relationship between vertices goes both ways. An important feature of the graph is the assignment of a label to each vertex. The label corresponds to the number used in that position. In graph theory, the labels of vertices are called colors. To solve the puzzle, one needs to assign a color to all vertices. The main rule of Sudoku is that each row, column, or region cannot have two the same numbers. Thus, two vertices that are connected cannot have the same color. This problem is called graph coloring, and as with other graph theory problems, there are many different algorithms that can be used to solve this problem, like for example, the grid coloring. So here's the illustration of the Sudoku puzzle. So it is a 9x9 grid and it has 81 vertices. So complicated na kayo na nga graph. Ang ato ang goal ani is to find the minimum number or the chromatic number of this problem. So how? So ang katong grid is represent nato siya as a vertex, and di ba sa Sudoku puzzle is ang rule ana is walay magbalik-balik nga number sa isa ka row, column, or region. So mao pud ato ang buhaton, dapat no two adjacent vertices nga magka-same og color. So diri sa kaning nga 9x9 grid, so the chromatic number is chi of G is equal to 9. So kay chromatic 9 chromatic man siya, so it is 9 colorable, at the same time it is 9 coloring. So that's all, but before I end this video, kanang take note no, when solving vertex coloring, we should always remember that no two adjacent vertices are colored with the same colors. So mura gid na ang murag K idea sa vertex coloring. So, I hope sa akong discussion is namin nasabtan. That's all. Thank you.